We discuss in this video the belief propagation algorithm in the case of graphical models represented as trees. In such models, each node has a single parent node and potentially several children nodes. The concept is that each node receives evidence from its children nodes that it will propagate upwards, and it will receive evidence from its parent that it will propagate downwards to its children nodes. We are going to divide the evidence into two, the E minus evidence coming from nodes in the subtree rooted in X, and the E plus evidence that comes from nodes elsewhere. And this is going to include obviously the ancestors of X, but it will also include nodes that are in these subtrees rooted in siblings of X. The point is that all of these nodes can pass their influence onto X via this parent node of X. So a key insight here is to realize that node X separates, in a sense that we discussed also in previous video, separates the E plus and the E minus evidence. So what this means is that we can in fact write this, that the probability of having the evidence E plus and E minus given X is in fact simply because X separates E plus and E minus. We have this product, so we can consider them separately. And similarly, as in a case of chain, we will have the following calculation. If we are looking for the probability of X given evidence E, again evidence E is made of these two parts, E plus and E minus, we can use the Bayes rule, and we will get that this is probability of E given X times P of X divided by the probability of E. And I'm just writing these two parts, P of E plus and E minus given X times probability of X divided by probability of E, or if you like, E plus E minus. And this is now equal just based on this observation that X separates E plus and E minus. So this is equal to probability of E plus given X times probability of E minus given X times probability of X divided by probability of E. And this is now, again, I'm applying the Bayes rule for this first factor in this product. So that's going to be probability of X given E plus times probability of E plus. Down here I'm going to have this P of X that gets combined with the P of E that I had already. And then I have the other terms up here. This is probability of E minus given X, and I have P of X. And this is now altogether, there is going to be a constant alpha times the probability of X given E plus times the probability of E minus given X. And that's exactly what we have defined as pi of X and as defined as lambda of X. So altogether what we end up with is just as in the case of chains. We have alpha times pi of X times lambda of X. So the point here is that, again, is the same reasoning. We need to figure out these recursive formulas for pi of X and for lambda X. And once we have them, that's going to help us to answer queries about any node in the tree given evidence anywhere else in the tree. So now, if X has m children, y1, y2, ym, then we can write this function lambda of X to be equal to, so by definition, remember this is P of the evidence E minus given X. And just like before, we are looking at this evidence somewhere here, and depending on X, and I'm going to introduce these children of X, so all of these intermediary nodes. and we introduce them in the following way. This is going to be a sum for all the children. I said that I have, in general, I have m children, and they are y1 all the way to ym. So that's going to give us the probability of E minus given x and yj times probability of yj given x. And because yj separates E minus and x, this is now possible to rewrite as a sum from 1 to m, probability of E minus given yj times probability of yj given x. And that gives us the recursive formula for lambda x. This is going to be sum for all the children of x by lambda of yj times the probability of yj given x. And a very similar reasoning also goes for the function pi of x is going to be equal to, so remember, by definition, this is about the probability of x given E plus, and the concept is exactly the same. I want x, and the evidence E plus is somewhere here, so I'm going to do that through the parent node of x, and I'm going to write it, this is equal to the probability of x given its parent node u and E plus times the probability of u given E plus. And again, the point is that this node u separates x and E plus, so that's going to be equal to probability of x given u times the probability of u given E plus. And then this is equal to p of x given u, and we realize that this term right here is exactly pi of u. And this again, gives us this recursive formula for the functions pi, and the whole discussion about how to initialize these recursive formulas is exactly as in the case of chains.